My name is Rituraj Kirti. I'm a software engineer at Meta. I tech lead the privacy infrastructure team. I was supposed to do this talk with my colleague Raj Kishan. Unfortunately, he could not be there with us today. So wish me luck as I go solo. Here's the agenda for today. We are going to take a look at what are some key privacy workflows for purpose limitation. We will take a look at some examples of how we are using GenAI to accelerate some of these workflows. And then we'll end it with some lessons learned. So what are these key privacy workflows for purpose limitation? How many of you were here last year for the banana talk that Diana and I did? All right, I see a few. All right, this year we're not going to do bananas anymore, but I will reprise. Purpose limitation is really, sounds very simple problem. It's data can or cannot be used for purpose Y. In practice, this can be fairly challenging. So we divide and conquer and divide into several parts, and we will look at those workflow details. For details on what we do, how we do purpose limitation, please take a look at our blog posts. I have a link to the blog we posted based on our banana talk last year. And we have done a few other blogs as well, describing data, how we find data at scale, how we use lineage to identify data flows, and so on. I'll give a quick overview of what the key privacy workflows are. First workflow is what we call understand. This is really about finding where the data is, right? This itself is a large problem. Finding a specific type of data can be challenging at our scale. The next workflow is what we call annotate. This is figuring out whether a piece of data that we found, is it really relevant to the privacy requirement that we are trying to implement? Some prior speakers mentioned context. This is really about applying context to the data. And then we have the workflow we call review. This is understanding data flows, where the data is going from the points that we have identified. Then we have techniques for enforcing to ensuring that we prevent regressions. These are techniques for runtime enforcement and checks, as well as things we can do before code lands using diff time checks and code assets. And finally, we have demonstrate. This is how we prove to ourselves that the whole system is working, whether we are meeting the privacy requirements or not. This has components of continuous verification, governance, and evidencing. In this talk, I'm going to take a look at examples from the middle three steps that I described here. Let's take a look at annotating data. To recap, we use different types of annotations. One type of annotation we use are what we call data annotations. These record facts about data. So, using our example for dating religion. So the requirement is of the form that religious preference data that is collected from dating product will not be used, for example, for things like showing you ads. So in this case, we have the semantic type that encodes the type of data annotation that is present in some asset. We also have a separate policy annotation, which represents the specific problem that we are, or privacy requirement that we are trying to implement, in this case, dating religion. This split allows us to handle our privacy requirements more flexibly and at scale, and keep a distinction between what type of data is contained from what policy we are trying to apply. Using GenAI classifiers allows us to scale out analyzing the context of data usage. We can use these classifiers to provide insights and suggestions. Also turn some of these high confidence insights into automated decisions and code mods. And these classifiers can be trained to use various different types of signals that we'll look at. We have Code Lemma that is trained on Meta's code base, as well as our documentation sources. We use prompt engineering to create classifiers for different types of signals. These then get combined and using weights to give us a predicted result. We use prior ground truth as well as ongoing feedback from the recommendations to keep fine-tuning the models. So let's go back to our example. Let's say for a hypothetical case, we are looking at an asset that has a semantic type annotation that might be interesting in scope of the product. But the question is this really relevant? Should we apply the policy label that we are trying to enforce? Or is this maybe a piece of infrastructure code, in which case we may want to apply a different policy? Typically, this is done by analyzing the code and the context and understanding how this data is being used. And this involves human decision making. Using GenAI, we can use it to give context about the type of problem. What does a type of infrastructure code looks like? Similarly, we could use prompts to train it on what does the dating religion policy code looks like. We also use prompts to have the GenAI, the models produce a classification result along with some reasoning, how it arrived at those conclusions. These are then used to create a recommendation, and then along with the reasoning that humans can look at and analyze. Another key problem is reviewing data flows. Oftentimes, we have stack traces that developers need to analyze to figure out if there is a data flow from a protected asset to somewhere it is not supposed to be going or not supposed to be going. This actually is a simplified version of a real stack trace from our production systems that was in reality about 326 frames deep, but I selected a few interesting frames from it. So here we're looking at some data that is being loaded. That's the top of the stack. And it's part of a request that is doing a GraphQL mutation. Now our question is, we need to understand where this data that is being loaded that is protected, what is the span of flow of that data? Does it actually go all the way to the request and gets maybe returned to the client? Or maybe the data flow stops somewhere in the middle and we can analyze just that portion of that stack. So we can use, again, GenAI classifiers to understand the context of the code, analyze each specific function and signature, and along with its code to understand what type of data it is reading or modifying, and what type of data it is returning, and classify whether this function is actually returning any sensitive data or not. These are then integrated into our tooling for stack trace analysis. And in this case, we can see that this data is being loaded, but it's being called as part of an observer of the initial mutation. So data is not flowing back from outside the observer boundary, and that's maybe a good place where you want to reclassify the data flow. Another example we have is of preventing regressions. You can see my example of trying to have Sherlock Holmes trying to prevent regressions. But all right, so we have, while we enforce policy checks at runtime, not everything can be runtime enforced. Because it may be because of either performance reasons, or sometimes we have very sensitive, very low frequency flows that we don't want to risk clobbering by turning up enforcement. Or we may have not adequate test coverage, so at diff time you may not be able to understand whether these flows will break or actually work. So using GenAI, we can also help accelerate and analyze the code to identify privacy risks. So in this case, we can parse code changes, have it suggest if there is a data read or write happening, then use that to understand and simulate the impact of the data read and write is that going to potentially trigger a disallowed data flow? And then use that simulation result to flag code changes at diff time. So here's again an example. Someone is loading the religious preference data, and we can detect the data flow and simulate it and say that this might be causing a disallowed data flow, so take a look at it. So what are some lessons learned? We have looked at some examples of using GenAI, and I'm going to share with you some of the key things that we learned. One is the biggest challenge with using GenAI, as you all know, is hallucinations, right? So how do you actually trust what it's producing is true and not confident wrong answer, right? So the best way we have found to mitigate for this is to keep the prompts very focused on a particular type of signal and to be able to both debug it and also to be able to minimize the risk of hallucinations. Second is you want a guardrail to understand what the results are being produced and have humans at various points of both the development of the classifier and prompt itself, as well as ongoing audits of that result. This connected with ground truth and feedback from developers' tooling and experiences can result in a pretty robust system. Another key point is using GenAI is expensive, right? And especially at the scale at which Meta operates, applying any of these techniques to make a real world difference can be quite challenging. So we had to do special pre-processing and hoisting a lot of the processing to pre-compute and cache results and apply across different requirements to make this scale. And finally, one key learning is the space is fast evolving. Similar attempts we did a few years ago had not so great results, but the newer models keep getting better and better, and the quality keeps improving. So these are already quite viable today, and we expect it to keep improving rapidly in the future. So thank you for listening. With that, open to any questions.